Welcome to our Spiritual Mathematics Week 2 class on intuitive circles. And let's begin with the meditation. Enjoy this Alex Morph soundtrack. Just bringing your attention to the eternal side of existence. We're seeking to identify not with the self-reflection, but rather with the essence. We're trying to see the dimension of the self that is essence. And the essence is the eternal aspect. We project that we exist in time. And yet every moment we are always now. We project that we exist in space, and yet every moment we're always here. By acknowledging these things, these projections, we can begin to see that eternal aspect of our being, which is timeless, spaceless, eternal. And when you're ready, coming out of the meditation, after we meditate, our minds are more pliable and they're more easily capable of taking the form of what we focus on. So if we want to transform our minds, a very effective method is to meditate and then focus on something that is a desired formation of the mind. Mathematics offers one of the most pure, transcendent structures, pure order, beyond language, beyond humanity, beyond opinion. However, there's lots of perspective and opinion and human artifact within mathematics because of cultural conformity. So in spiritual mathematics, we seek to look beyond the cultural agreements in mathematics and try to break free of them. Can we see what is pure truth in mathematics? Now, are there shades of truth? Does everybody have their own truth? Or is truth singular? Is truth the perception of what is? Or is it what is itself, perhaps even more? A lot of people like to feel that they have their own truth, and the truth may be that they are in a particular state of mind. If truth is suchness, isness, the truth is that there's a rock there, there's food there, that I am being selfish or I am being kind, I am thinking of myself first and others second, or I'm thinking of the totality first and me second, or just the totality. These are all truths. They're what's actually occurring. It's a very important thing on the spiritual path to recognize what truth is and what delusion is. Delusion is colored with like and dislike. It's colored, it also may include the misapprehension of what's actually going on, right? So you think you're humble, but you're not humble. lots of things that all of us have to grapple with as human beings. Is that the truth? Krishnamurti, one of my favorite people, he would have people give him a hard time. So a guy would come up to him in his talks and he would say, you just love to hear yourself speak or something like that. And you just keep talking, but you don't do anything or something like that. And he would take his time and spend a few days considering what that person said. Am I what this person said? And he would practice seeing himself clearly, truly comprehending himself, his actual movements of his mind, the actuality of it. So this is the truth. And truth can be searing, it can be painful if you're attached. But the truth is always liberating, though. You may say, oh, I'm the smartest person in the world. And maybe you're not. And maybe you find the truth that you're not. But as long as we're hiding in delusion, there's a sort of, in our subconscious, a lack of peace. There's certainly a lack of love. If I have to be the smartest person in the world to accept myself and to love myself, then that's a major burden, right? So truth is a very beautiful thing, and where truth is, there's love too, because love is acceptance. Love is therefore more capable of perceiving what is. You can't see what is if you don't want to see it. Now, and the intellect, the thoughts, if they're not still, you only perceive them. But if the mind can look at what is and not through the thoughts, and let thoughts have their rightful place as a description of what is, then that is a healthy way to think. And these are all actually really lovely lessons that Krishnamurti talks about. And this is the book I'd like to recommend you guys read. Every parent, I would like to read this, of The Seekers. It's called Education and the Significance of Life, and it's one of my favorite books. I've read it many times. Um, it's a small little book, and for Krishnamurti, it's a little unusual because many of his books are transcriptions of his talks. But as far as I can tell, this book was an actual written. Uh, he sat down and wrote this one, and in a way, I am seeking to um, continue his mission in this book. It's a little bit of a mission statement, and so he talks about some wonderful things like education should develop the whole individual. It should not be a means simply to develop proficiency. Uh, so he talks about mathematics. He even says, when you learn mathematics or geography or something, usually, that's about proficiency. So we'd like to make this study of mathematics for us and for any of the students that any of us may have, or for our children. Robert has a child. Um, so this is an opportunity, and for our friends and our family, everybody. Education should bring us more further into freedom. And truth is a very central um, aspect of that. Truth means seeing yourself truly, seeing the universe truly, and ultimately, truth comes down to love and beauty. If you have truth, you have love, and you can apprehend the world in its full splendor and beauty. And there's so much beauty when the mind is healthy, when the mind is clear. It's so beautiful. And I'm not talking about just, oh, I saw something beautiful with my senses. You become a movement of beauty. There's a beautiful radiance, a divinity, a sacredness inside of us. And you could be looking at the same tree and it could be profoundly beautiful. A moment that really is, if you're not bringing, it's not bringing tears to your eyes outwardly, it's doing it inwardly. There's this move, and you're moved. So if we're going to have a beautiful experience of mathematics, we need to become capable of seeing the tree in its full splendor and beauty, so we can see the mathematics like that. And this is a real philosopher, a real mathematician, which I don't feel exists in a significant way in this world. We're not very much trained to be this, where we're tested not for this, we're tested for other things. We're encouraged not to be this. But if you look at the real great philosophers and mathematicians in history, they lived with the state of wonder and awe, and inwardly they cultivated as they did outwardly. So that's my little intro. So I highly recommend Krishnamurti, Education and the Significance of Life. Read it this week, read it this month, read it tomorrow. Whatever, depends on how fast you read. And you can just read a couple of pages a day. If you don't have time to read a couple of pages a day. It'll put you on the wavelength of this sort of refined energy. You open the book, you're like, oh, I feel better. Just to read a couple pages. Okay, so let me check these chat comments in case anybody said anything. Right. Oh, thank you, Jacob, for putting that on there. Namaste, everybody. Okay, so I sat down and created a custom animation just for this class, which is a really wonderful thing that I would like to. I've always wanted to do that because I'd rather do the class right, and that means there should be a custom animation for each topic instead of drawing on a whiteboard or even using Desmos, which is pretty good, but not ideal. So let's begin by taking a look at this custom animation. Play it. Can you guys see it? Notice there are no symbols.
I
Yeah,
see the
Russ?
code for it. Not the, I see just code right now.
You just see code. Okay. Can you see it now?
Yep. Yeah, like a gradient of triangles.
Oh, let me try again. Oops. So let's try one more time. Can you see this, the circles? So in a way, you can just observe this. What is this showing us? So we see a circle transforming into a whole bunch of triangles. And it's not a circle, it's a polygon, right? But because it has many sides, but as we increase the number of sides, we begin to approach the circle. Now, why might we do this? Well, doing this allows us to transform the area of the circle into an area of a rectangle. And you might say, well, that's not a rectangle. Well, in the limit, it's a rectangle. As we continue to get in the limit, it's a circle. So really, we're showing all these steps so that we have a better understanding of what happens when there's an infinite number of sides. Okay. So now, mathematics, if it becomes perception first and description second, then we're doing mathematics like the greats who opened the windows to the cosmos for us, right? And then they showed us this. So what is the length of this rectangle? Now, notice we actually have two circles, don't we? So two circles transforms into this long rectangle, right? Not one. And this is not the only way to look at this, by the way. We could have perhaps taken the top half of the circle and the bottom half of the circle and put them together. But I went with this one particular method, which is to take two circles and fit them perfectly together, just like a cone. So let's get some comments. I'd love to hear what people think. And we're still getting more and more triangles every time, by the way. It goes up by 20 every time. And soon it will be slowing down my computer. Oh, that was the last one. So I'll start it over. So Jacob, I'd love to hear from you. Jacob is a grad student in physics. He's a very smart person, but I'm wondering, did you ever learn about a circle like this? Oh, you're muted or something is not correct. Or I don't think you're muted, actually, you're something else. All right, how about you, Robert? Robert's a math teacher, ex-math teacher, current math teacher in a new form.
Indeed.
What do you think?
Well, yeah, Jacob, I don't know why your thing says you're unmuted, but we couldn't hear you. Yeah, I don't know what comes to mind. I just see, obviously it turns into a rect or a parallelogram, and you see the height of that being the radius of the circle, and the length is going to be the circumference around the circle.
Okay.
Well,
So radius
where it leads me. Yeah.
times circumference would be the area of two circles. So what's the area of one circle?
So,
Well,
well,
area of two circles is the radius times the circumference, just in terms of radius and circumference. Let's just start with that. It's, so two circles is the radius times the circumference. So one circle, just half of that. Half the radius times the circumference. But that's a funny way. The thing is, nobody ever says it like that, right? The area of a circle is half the radius times the circumference. It's a very non-conventional way to describe area equals radius times circumference divided by 2. All right, Jacob, I'd love to hear from you.
Can you hear me now?
Great.
Hello.
Hi. So what do you
Hi.
think?
Oh, I agree.
Hmm.
So each circle is you have your length, that's your, when it comes to rectangle, it's 2 pi 2 pi r, and then the height is r. So but when you combine them, then there's 2 of them. So when you take the area of just one circle, then it really becomes just pi r squared. But
So if we were to say pi r squared, could we say it and have it be a specific description, like the sky is blue and the grass is green? So pi r squared, can that describe specifically what we mean? Let's say, let's go to, I think it's 32. So what is actually being said here? Right, that's, oh, not 32, let's go to 31. 31 seconds. Sorry, I happen to know the duration of each of these little scenes. Okay, so here's the 31 seconds. So what's actually being said here is that we have the length of this rectangle is the distance around a circle times the radius is the height of the rectangle. So that would be the area of the rectangle and half. So what is pi? If we want to introduce pi, really pi isn't in here as much. It's actually more tau or 2 pi. So this length is some number of radii, 6.28 times the radius. Now what's the radius? It's this. So we have 6.28 of these going that way. And 6.28 by definition is tau. So tau literally is the answer to the question, how many of these radii go into this length around? It is the answer to that question. It doesn't come from something else. It is the answer to that question. So it's a little funny. It's almost like we're answering our question with an answer, but it's the number of times the radius goes around the circle. Let's call that by this symbol, times the radius would be how long that is. Right, because 6.28 isn't the length of it, it's 6.28 Rs is the length of it, right? And then that is the width and the height is R, and that equals 2 areas. You see, I'm describing it explicitly based on what I'm seeing. Now, another thing we could do is say, hey, Adam, isn't that a square R? Isn't that a square R? Isn't that a square R? Oh, wait, so these are all R squareds, or R times Rs. Each of those, right? So how many of those do we have? Okay, so tau R squareds, tau times R equals 2 areas. You're probably wondering, well, why don't you just say pi r squared? Well, the goal is to, pi r squared is a very succinct description, but it's just so popular, and we can be almost wary of it. We're just parroting what we've been saying since we were 12, right? Or perhaps younger, perhaps older. But if we look at this, we see there are tau r squareds, tau r squareds. And we've introduced language here, right? Tau is language, but r with this little 2 is also language. So try to see this not by the name, which is language, but just by the direct perception of it, right? So if I look at this, I can see, okay, there's r squareds, there's the number of, there's little squares that are like the distance from the center of the circle by the distance of the center of the circle. And there happen to be, how many of those? Well, the number of times the distance to the center goes around, that's how many of these squares there are, right? So, any questions? Hey, Ayush. Question from Ayush.
Oh, we can't hear you.
Oh, you can't hear me.
No, we can't hear Ayush.
Oh, okay. Robert, what do you think?
What do I think about what?
I don't know, feedback, maybe from your educational experience. Maybe you're welcome to challenge me on anything. You can say, yeah, but this, or yeah, but that, or I'd love, that can be a contribution if you do that. Or you can also be like, oh, would be so much better if we learned it that way in school. Or I'd love to hear, from your personal life experience and your mathematical interest. If there's anything you have to share.
Yeah, I think what you were saying that, well, math's like in school, they just do it linear, it's, oh, this is what you learn at this point, at this point, at this point. And when you take the different approach and look at it like this, and like have the kids ingest this direct perception of how it should be, rather than, you have to do it in order. I really like how you're approaching this, and it forces you to look at, the area of a circle in quite a different manner.
Right.
You're looking at this rectangle and it's like, oh, I know that.
Right.
I know that is, where a circle is just so scary for a lot of kids, and that, throwing in a pi or a tau in there makes it scary. So it's a good way to really break it down into simpler components.
And what's nice is when you become your own authority. So you can see something as self-evident because you perceived it directly, and therefore you're your own authority, and nobody can tell you otherwise. Instead of just taking somebody's word for it, you become somewhat precarious. Oh, so-and-so told me this is the equation. I don't understand it. I may not know how to use it, things like that. So now the first step is perception, and then description. We can start describing it, but then we can even take it further and go to application. And we can actually solve things without ever having used the equation at all. Now that's an interesting approach, right? If we solve something, but we're not kind of resting on using an equation as a scapegoat, right? We were like, okay, well, I'm not going to use my mind in an abstract way. I'm just going to see if I can use the equation. Now, what's the equation? Well, it basically comes down to arithmetic. Take this number times this number times this number, and voila, you get the answer. But that's not the experience of a circle or the comprehension of it. That's you may not have any comprehension of it and just be plugging numbers into this equation and getting answers. And for that, you get an A. Congratulations. You just didn't do mathematics and we pretended you did. Right? I mean, you did in a sense that you were able to make a calculation. But what about math is calculation and what about it is beyond calculation, right? And if calculation is a description of a deeper insight, then calculation becomes much more easy because you don't have to, you know what to do in more abstract situations, perhaps. Like, what if the situation, like, what if we said, what's the area of a circle on a sphere? Could we apply this and find out what the area of a circle reflected radially onto a sphere is, right? So this becomes non-Euclidean geometry, and we could perhaps actually use the same equation and show that it would indeed be, well, I mean, well, it would be a similar equation, right? Actually, maybe we can do this in the. See, I haven't ever actually thought of it in this way, so I would be looking for the first time. But there's a lot of confidence, right? When I look at it and I say, it's not about did I remember the equation from that class a long time ago, which I happen to not take, the non-Euclidean geometry class. I never took that class in school, at least. Definitely given it a lot of thought, probably more than I would have had I taken the class, but because I really love the topic. But we could start asking more complicated questions now because they're rooted in perception. And truth and perception go together. What we see without the lens of like and dislike directly, that begins to approach truth or is truth. Some people won't like it when you say truth. They feel exposed by it. And this is your truth, this is my truth. Well, I would challenge them intensely, personally, because I think that's a very dangerous perspective. You need to, when people say that, that is the cause for division in society. This is my beliefs, that's your beliefs, we don't like each other. Well, if we commune in the truth, we will all be one humanity. So it's an important part of the peace on earth and between each other and our relationships. So, Ayush, would you like to say anything? It's interesting because this is almost like a very short lesson, right? At this point, I could say there's a lesson. And this is why my 90-second videos sometimes work quite well, because there's a lesson. But what can we do to take this beyond a 90-second video? All these things I'm saying are included in it that I don't get a chance to say on my videos. Now, you could sit and meditate on this as well, right? You can just sit and be with it. I mean, perhaps I should be quiet for a few minutes, but let's hear from Ayush. Ayush, you got to be more on top of your speaker situation. All right, we're not waiting for you, Ayush. That was your second chance. Okay, so would you like to talk? Yeah, we can't hear you. Okay. Now, if we were to perhaps take this as two half circles, one on top, one on bottom, then we would have half tau. Pi is really not the correct number to use here. The pi is the proportion of the distance around to the distance across. And the distance across doesn't really intuitively help us in this situation. Now, why would we're going to end up with a tau divided by 2, which people want to distill it into its simplest form. But sometimes the simplest form isn't the best form. If we're prioritizing simplicity and succinctness, then it is. But if we're prioritizing the accurate description of an intuitive insight, then it's not, right? So we can say it's 1/2 or tau r squared is divided by 2. We could say it's tau times circumference. We could say it's circumference times radius divided by 2. Those are 2 ways to say this. Now, I would really encourage kids and ourselves to say circumference times radius divided by 2, because there are situations where I might say, hey, the circumference is this and the radius is this. What's the area? And you know it's just the product of those 2 numbers divided by 2. And sure, there's a relationship between circumference and radius, right? But you already have circumference and radius.
And that like makes sense. Because like if you want to think of like the area as just a bunch of circumferences, you know, getting increasingly bigger and bigger and bigger, or smaller and smaller, smaller, then all those rings together make up the area of a circle.
Ooh, wait, you're talking about the rings now.
Yeah, so you take the circumference, and when you multiply by the radius, and it becomes the area, well, the circumference times the radius divided by 2. If you want to think of it as just, you know, little rings building up from, or infinitesimally small rings building up, you know, into the actual circle, and take it, and have those all the little areas adding up.
So if we had a ring,
Yeah.
we could actually say that a circle is not made up of triangles like this or in the limit, but rather rings in the limit.
Yes.
Okay, so this is excellent, Jacob. So this is another intuitive way of seeing the area of the circle, which I haven't animated here. So now the first question I'd have, though, is, wait, you can't make these rings straight, though, right? If this is a ring, right, with an area like this,
Yeah.
we can't really make that straight because they would kind of crack, right? If you try to straighten that, it would crack, right? But if you make these very, very thin, like you said, infinitesimally thin, which we can represent by dr.
Yep.
Okay, we're going to take this into calculus space. Let's just do that. So if we represent that by dr, you see, the thing about really comprehending it in geometry class means that you're going to start comprehending it better in calculus, because these things come up in calculus and geometry in all different math. It really helps to build what I would call a strong integral core of comprehension. So, okay, so this is dr, which means an infinitely thin radius. Now that you could actually straighten out, because the top and the bottom are basically nearly the same length. And if it's infinitely thin, they are the same length. You understand? So if you were to kind of, you'd have to kind of do this, you know, at first. But if you get very thin, this starts to look flat. I don't know. So if we think of it a bunch of rings, then how would those rings lay out? The biggest ring would be here. The smallest ring would be here. And the rings would actually, layered on top of each other, would make a triangle, right?